Okay, I'm going to start class. So today's topic is, it is also one of the combination circuits. Previously we discussed half adder and full adder. Now we will discuss of subtractor and full subtractor and their functionality and how it works. Okay, come listen here. It is similarly like the full adder and half adder, but some little differences there in the functionality. We'll discuss now. Now come on of subtractor. Of subtractor. So what it does definition, generally it subtract, subtracts or difference two binary numbers and subtracts two and produce numbers. Subtractor and borrow. Okay, this is one of the definition, and
తెమ్మనే ఫోన్ చేసి
it is a two input and these are two input and output. Similarly like that. Now come here. Block diagram. So consider one box. The two inputs and two outputs. Input A, B. Subtractor. Okay. And produces difference of subtractor. One is bar. Okay, are you getting it? So this is a block diagram of subtractor and definition. It subtracts or difference to binary number and produces output as subtractor and borrow. And it is a two input and two output gate. And the following diagram is a block diagram of the circuit. Now we'll discuss a truth table and functionality. Let's consider two inputs. We require two inputs, right? So for that, I'm considering A and B as inputs. And difference and borrow. Okay, these are the two inputs and two outputs. So I will divide it. So two inputs in the sense how many possible combination of inputs. Okay. Just considering one output as 0, another one is 0. Similarly, for 0, 1, 1, 0, 1, 1. So I have taken four possible inputs. Now, come on. You just need to differentiate. Subtractor means we need to difference, right? So 0 minus 0, what is the output? Come on, quick response, guys.
0, sir.
Yes. So 0, we are not taking any borrow. So borrow is also 0. Okay, just remember 0 minus 0 equals to 0. Similarly, we have 0, 1, right? Can you do this like 0 minus 1? What is output? Minus 1, right? So minus 1 we can't like do in circuits. So for that we'll take like 0 and 1 and consider one borrow here. Take one borrow. So 1 0 will become now is equals is equals 2. Now 2 minus 1. Output will be what is output? 2 minus 1. 1. Right? So subtractor will be 1. Difference 1 and borrow is 1. We taken one borrow, right? 1 0. 0 minus 1. Now similarly 1 minus 0. 1 minus 0. So 1. We don't require any borrow. So difference is 0 1. Borrow is 0. Similarly 1 minus 1. 1 minus 1 is equals 0. Do we require any borrows? No. So output will be 0 and borrow will be 0. Now we need to find the expression to make a circuit, right? So based on the table, now find out the K map. Using K map, we need to find out some expression, right? So now consider K map for difference, okay? K map for difference, okay? Now take two inputs. So it is how many inputs we have? A, B. So what is how many cells do we require for the K map? 2 power 2. That is 4 cells. Just consider. Charan, are you getting it right?
Yes, sir. Yes, sir.
Yeah, just focus, okay? So just write here A, B. So here B bar, B, A bar, A. So basically this is 0, this is 1, this is 2, this is 3, right? This is the K-min. Now come here. How many ones are there in difference? At 1, we have 1. At 2, we have 1. So just write 1 and 1. Now what will be the function for here? What is the row or I'm just writing directly. Difference equals to now expression a bar into. So there is no pairs, right? There is no adjacent one to pair up. So just we will look it into the row and column. So we have a bar into b. So right, a bar into b plus now come here. Similar down one. A bar in a bar. Sorry, a into b bar. B bar. How the expression is look like? Come on first.
XOR gate.
Yes,
XOR
good.
gate.
Yes, good. Perfect. So you know how to solve. So the expression for difference will get this. Now we need to find the KMF for borrow. Okay. Similarly, come take two inputs. So KMF for borrow. Okay. Now focus. Take two inputs. Bar B, a bar A. And this is 0, 1, 2, 3. Okay. This is the KMF for borrow. How many ones are there borrow in the borrow? Here borrow. Only one. That is at 0, 1. See, that is at 1. Here we'll get 1. So it is a single. So we don't need to pair anything. So what will be the expression for it? Now you need to tell me bar equals to. Guys, come on. What is the
Sir,
answer?
A bar B.
Yes. A bar B is the output,
A bar. Yes, sir.
right? So we got to
Yes, sir.
expression, and based on that we need to design a circuit of adder. Okay, circuit. Okay. How many inputs we have, and how many XOR gate we require? Two inputs, one XOR gate, and how many AND gate? Just tell me how many gates we require based on the expression that we got.
Two gates, sir. One XOR gate and one AND gate.
Okay, that's right. Let's see how many gates will take. Okay, just consider one input A and B. So we need one XOR gate. So I'll write okay, one XOR gate and one is AND gate. Now, what are the A into B, right? So I'm just connecting A into B. Simply I will connect. Just focus how I'm doing. Okay. So first expression is over. Okay. Now what are the expressions for borrow we have? So one is B, right? So I'm just connecting B. So what next we have? Come on, Charan, quick. Come on, answer me. Which gets sorry.
Not get.
Yes, yes, exactly. Why we require not get? Come on, answer. Response. Any response? Fast, fast, fast. We don't have time.
I can't hear. One second.
Why do we require and get? Sorry, 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 sorry. Not get, not get, not get. Right? Is this correct? Come on, quick answer. Just observe the circuit and tell me. Is there any wrong or is it correct? Come on, quick.
So you didn't use the not get, sir.
Yes. Why we did use? Why we use and get? Not get, not get.
Because if
Hey, come on. Don't worry. Tell me.
if there is a bar, then we use if there is a bar, then we use not get.
Not
The
get.
bar indicates the not
Yes.
uh,
Yes. Perfect. Perfect. So
not get.
for that I will use one and get. Simple. Not get. Sorry. Just add a not gate here. Now is it correct? Now what will be output of this? See, this is
Yes, sir.
the
A bar
yes.
and B. A B. A bar B.
Now it looks like perfect.
Yes, sir.
So this is the circuit for half subtractor. What we just done when I take the functionality that is inputs, then I just draw a schema for difference and borrow, and I found like the expressions. Based on the expression, I design a circuit. Similarly, we have another gate that is full subtractor. Okay, come here. Full subtractor definition. So it subtracts or differences three binary number. Three binary numbers and produces this two outputs. Outputs as difference and borrow. Am I right? And it is a 3 input put in to output gate or circuit. And block diagram for this. Now just consider a box. Yeah. And just connect 3 inputs. Input 1, 2, input 3. And how many outputs? 2 outputs. Yeah. Full subtractor. Input A, B, C. And output bar. Okay. This is the block diagram for the full subtractor. And what it does just differences or subtracts 3 binary numbers and gives outputs as difference and borrow. So let's discuss the functionality of this. We require 3 inputs, that is A, B, C, difference and borrow. So we have 3 inputs, right? How many possible combination we require for inputs?
2 power 3,
Yes, good.
8.
Means 8 combinations we require, right? So what are they?
Yes, sir. So 3 inputs is compulsory, sir, or more than 3 or less than
No, no, no.
for full supply?
No, no, only three inputs. Because just see the block diagram.
Yes, sir, seeing, sir.
Yeah, only 3 inputs required and it will give 2 outputs. If it is a multiplexer, you can keep 2 power n number of inputs and will get only one output.
Okay, sir.
So we are just designing according to our requirement. So I need only a circuit
3
which
input.
takes 3 inputs and gives 2 outputs.
2 outputs. Okay, sir.
Yeah,
Okay,
perfect.
understood.
See? So you remember the three possible, like 2 power 3 possible inputs. 0, 0, and the decimals. It's very important. Just remember, don't forget that. 1, 0, 1, 0. 0, 0. Mm. Okay, please pay attention. It requires it requires full concentration to understand the functionality of this truth table and the functionality of the output and input. Okay. So what I'm doing, see, first on first numbers we have 0 minus 0 minus 0. So what is the output?
0.
Yeah, 0. And do we take any borrows? No. So just write 0, 0. Next we have 0 minus 0 minus 1. So just consider 0 minus 0 equals to 0. Okay. Again 0
0.
minus 1. So what is the functionality?
1. Minus 1.
Yeah, minus 1, right?
2 power.
Yeah. 0 minus 1. So it's not countable. So we can't keep minus 1 in binary form, right? So just take one borrow. Okay. So I'm just considering 1 0 minus 1. That is 2 minus 1 equals to 1. Okay. So we'll get difference as 1 and borrow as 1. Are you getting it right? Or you want me to explain again?
Sir, where are you taking the borrow, sir? I am not understanding
Okay,
about
wait.
borrow.
So just consider here. What are the inputs we have? 0 0 1, right? So just do one by one. 0 minus 0. Okay. First 0 minus 0. What will get? 0, right? Again, what we have?
0.
1.
0
Okay.
minus 1.
Yeah. 0 minus 1, right? So
Mm.
do we, can we, is it available to do the like this? So 0 minus 1. Can we do minus? Can we take 1 from 0? No, right? So for that,
No,
we'll
sir.
take one borrow here. Just take 1. So now 1 0 will become
Okay, okay. 2.
2,
Yeah,
right?
okay, sir.
And what we have on a 1. So just
1.
minus 1 is equals
1.
1. So we'll get
Okay.
the difference
Now
as
I
1. Yes. You get it right? One borrow and one difference.
okay, sir.
Now similarly, again we have 0 minus 1. 0 minus 1. That is same.
Minus 1.
Minus 1. So for that, what we will do? Take one borrow and do.
Mm.
Okay. So 0 minus 1. What will be the output? It means what will be the difference?
1, sir.
1. Again 1 minus 0
Mm.
is
Minus
equals
0. 1.
1.
1.
So answer is 1.
No.
Borrow is 1.
Borrow 1.
See.
Yes, sir.
Okay. 0 minus 1. Sorry, I'll do it again. Just focus. 0 minus 1. Do we eligible to do it? No. So just write it 0, 1. Just consider here 0 minus 1. So we can't do it, right? So take one borrow. So I'm taking one borrow here. 1. So 1 0 will become now 2 in decimal form. And what we have? 1 is equals to, the answer will be 1. So difference will become 1 and borrow will become, come on guys,
1, 1, sir. 1.
wait a second. Come back. Where we are? So here 0 1 1, right? 0 1
Yes,
1
sir.
is our input.
Borrow.
So 0 minus 1 we can't do, right? So we take one borrow
Mm.
and we get
Yes, sir. 1
difference as
borrow.
1. Okay, right? Again we have that
1.
is minus 1, right?
Uh,
minus
1
1.
minus 0.
What is the 1 minus 1?
0. Okay.
So, so this become 0. This is 0. And we take
So,
one bar, right? It is 1. Simple, right? I hope you understand this. 0 minus 1 is not allowed. So for that we are taking one bar, that is 1. So now input become
yes,
1
sir.
0 minus 1. So it automatically converts 1 0 into decimal, that is 2. 2 minus 1, again 1. And we have C is 1. So 1 minus 1, 0. So borrow is 1, output will be 0. Next we have 1 0 0 as inputs, right? I'm taking 1 minus 0, that is 1 minus 0,
1, 1.
1. Again we have 0.
1 minus 0. Again, 1.
So 1. So difference will be
Different 1, borrow
borrow.
0.
Yes, good. Similarly, this. Again we have 1 0. 1 minus 0 is equals to 0.
1, 1, 1.
Sorry, 1. Again we have 1.
1 minus 1, 0.
1 minus 1 is equals 0. So output will be, I mean, difference is 0 and as well as borrow is also 0.
0 also.
Getting it? Same again. Similarly, we have 1 1 0. 1 minus 1, that is 0. You see here, 1 minus 1,
Hmm.
0.
Yes, sir, 0.
0 minus
0
0
minus
is equals
0.
0. So difference
0.
is 0. There is no borrow. So it become 1. Sorry, 0. You got it right?
Hmm.
And the last one is
Yes,
1
sir.
minus 1 is equals 0. Okay,
0 minus
1. So the difference will be 1 and borrow is
1 equals
1.
to 1.
Yes. So 1 and 1. You got it right?
Yes, sir.
Yeah. This is the
Sir.
function working functionality of the full subtractor. Working. So what we need to do now? So what is the next step to do? Come on, quick.
Hmm.
K map for
Okay, ma'am.
don't don't forget it, yeah.
Yes,
Just
sure.
remember what we did for. So just K map for difference.
Different.
Okay. How many
Sure.
inputs we have?
1, 2, 3, 4.
What?
Here, okay.
How many
Three
inputs?
inputs. 3 inputs.
Yeah, 3 inputs. So 2
3.
power 3, 8. How many boxes we require?
8 boxes.
Yes, perfect. So I'm considering this.
A, B, C. Yes, sir.
Yeah, consider. So 3 inputs. That is, I'm taking A and BC, right? So next, take 8 boxes and so the meeting will end in 2 minutes. Please rejoin, okay?
Okay, sir. Okay.
It's a technical problem we are having. So please cooperate. Yeah. So A bar A. Here we have B bar C bar. B bar C. BC. BC bar. So this is a K map for difference. And now, and you remember the values, right? 0, 1, 3, 2, 4, 5, 7, 6. Now come to difference. How many zeros? Like, difference where 1 we have at 1, 0, 0, 1. That is 1. At 1 we have 1. Again 0, 1, 0. That is 2. We have 1.
2.
Yeah.
Mm.
4 and 7. 1, 2, 4, 7.
Yes, sir.
Yeah. So 1.
1, 2, 4, 7.
So do you see any pair? No.
No,
Do
sir.
you see any chord? No. Do you see any octal? No.
No, sir.
So there is no like alternate ones and adjacent ones. So simply we'll go for single.
Yes, sir. Single.
Yeah. Now I'm just firstly I'm doing here. Now take first we'll solve that is at 1. A row has A bar and column has B bar C. Okay. Justly I'm doing it. Reference that is first one. A bar, B bar, C bar. Right? Are you getting it right? First one.
Yes, sir. Yes, sir.
And
Next.
yeah, next A bar,
A,
B. Yeah, tell me, tell
B,
me.
C bar.
Yes, good,
A
perfect.
bar,
And next plus
A, B bar, C bar.
done.